Hi, so this is experiment number 8, construction and testing of a spectrometer for quantitative analysis. We're going to use the Shimadzu double beam spectrophotometer, the one that you used before, and we're also going to construct a spectrometer similar to the one that you would have built for the colorimeter, but this one we're going to actually take a spectrum using it. So we'll talk more about the construction of the actual instrument here and how to use the software to control the homemade system. So what you find when you come in is a box with all the stuff. Take out components. This here is your detector, and it's also got your diffraction grating on here. But you'll actually see it's a thin piece of plastic, and it's kind of highly coloured. So that's going to be your detector. Put that to one side. You're going to have a light source, just an LED light source. Plug it in, and there's a little switch on it as well that you can see down here. So same as you've used before. You're also going to have this polarizer. It's a cross polarizer, and by rotating this little wheel around the side of it, you can actually change the amount of light that actually passes through that. So you're going to be adjusting that to give you the best level of light reaching your detector. You've got lids, you've got a slit, okay, which will control the amount of light that's actually entering in the spectrometer. This is quite a wide slit. Again, with more lids. And we've also got our sample holder, the same as what you've used before. You're going to have your little optical base plate, so you need to screw that down onto this metal bracket here. So I'll go through the construction of the instrument now. I'll just assemble it, and I'll cut to that now in a second. So the first thing to do will be to screw down using the M6 nuts and the driver that you've got here, and make sure it's secured in place. So make sure you put in all of the bolts and make sure they're tightened down. It doesn't need to be over tightened. Same as what you've done when you were building the colorimeter. So that's the base plate in place, nice and secure. First thing that we want is our light source. So we'll take our light source, just an LED. We'll plug it in, switch it on, turn on the little switch here, and you should see it lightens up. Put the little Lego blocky things down into position. The next thing you're going to use is the polarizer. So this will just place straight down as well. Put the lids on top. I'll do that at the end, I suppose. The next thing you're going to want to place in here is your cuvette holder. And we're going to do it that way. Make sure they're all well and secured down. Following on from that, it's your slit. And the last one then is your grating camera system. So we'll push that in at the very, very end. That should go in. Oh, just upside down. Now, connect this USB cable up to the PC. One of the available ports here at the side of the PC that actually is also used to control the UV vis spectrometer. So we'll just plug that in here. Doesn't matter which one you plug it into. So once we've got that all set up, put your lids on. Now I'll leave the lid off the polarizer for the time being, because I'm going to have to adjust that to vary the intensity of the light that's reaching my detector. Place on your cuvette holder, and that's it. So that's the spectrometer built. So I'll run you through the software now. So we're going to double click on this icon here, spectrograph. It'll come up with this green screen. Give it a second, and it should load. There we go. Maximize that screen by just clicking this button up here. First thing you go to is Acquire, up here at the top. Go to Device Type over here. Select USB webcam. It'll automatically detect the camera, and click Connect, this icon here. You should see this window pop up. It'll be black for the time being because there's no light getting through. Change this icon here from single shot to continuous and click Acquire. And what we should see is this bright image that's appeared. Now what we're going to do is we're going to set a wavelength range by clicking this icon here, and I'm going to change that number here to 400. I'm going to change this number here to about 700. That's kind of the limit of this system, all right? Once I've done that, the next thing I'm going to click inside this white box, and you'll see these little green icons. I want you to adjust them so it's kind of about the edge of this, and drag this one over here so we can actually get the tail end of it. And you can readjust it to whatever you want. Now this is quite bright at the minute. It's showing a nice broad speed. If we adjust the polarizer, the rotation on the polarizer, I want you to observe now what happens when I adjust the polarizer. You'll see the intensity is dropping, but the image intensity is also dropping here as well. And if I have it completely crossed, I completely blank out everything, all right? If I bring it back in and keep rotating it, I'll get a nice bright, and that's aim for about 120 on this scale on that peak, and that should be sufficient. What I'm going to do is I'm going to minimize this window just for the time being and put it to one side so you can still see it. And what I want you to see is when I place my sample in, you'll see a component here in the middle disappearing. First thing I'm going to do is going to change the number of times I average this. So click the averaging button and let's put it up to about 9 averages. So it's going to take the average of 9 scans and add them, and take the mean value of that. The first thing we're going to do is click on reference spectrum, set reference spectrum. I want you to then turn off the light source. You'll see it goes black here. And click on the drop down menu and set as dark spectrum. Okay. Once I've done that, I want you to click on turn the light back on. You'll see it coming back on. And I want you to change the measurement mode from intensity counts to absorbance. And we'll see it there's very little going on down here at the bottom. Okay. So what I'm going to do now is I'm going to place a sample in and you'll see a peak. So I'm going to take my unknown sample here. It should be red. This is metal orange. It's in the acidic form. So its color will be different from the metal red orange that you used before, which was in the basic form. So it should be red, and you should basically all your solutions should have a red tint to them. So I'm going to place that now into the cuvette holder. I'm also going to place the polarizer cover back on now that I've set the polarizer. What you should see is that some of the color has changed, but more importantly, I can see down here, I'm reading an absorbance value. Now I can zoom in on this by just clicking and dragging and holding it, and I'll see there's an absorbance band here. Okay, it's not very smooth, it's not very great, but you know, it is what it is. We're going to measure the height of this peak as a function of the concentration. We're going to also run the same samples on the commercial spectrometer, the Shimadzu that's sitting beside it here. Okay, so you do your analysis on both systems similar to the way that you did it for the colorimeter. Okay, do your calibrations, do them in duplicate, and then measure your unknown on both systems, and you should see some sort of correlation between the two of them. If you wish, you can increase the averaging that you take. Okay, you could record a blank spectrum by just using water and setting it into the spectrometer, and all of those parameters might improve the measurement that you obtain. So it's a pretty simple system. It's a USB webcam that's been converted to provide a spectrum. And if we compare that spectrum to the one that we get from the commercial system, I'm going to put them side by side, you can see that there's a good correlation between the two of them. So I'm going to do that now. So open up the spectrometer software for the commercial system. Click on baseline, set your wavelength range to the same, 700 to 400, always start high and work low. Click OK, it'll run a background. We're just doing an air background. You could put empty cuvettes in there, or cuvettes with the solvent that you're using in there for your background as well. It really isn't that necessary. You can see it now running. We're doing this at a medium speed with a 1 nanometer resolution. That's probably the limit of what you can get from the homemade system. So we'll do a comparative analysis of the two of them. That'll take a few seconds to run a background. We'll pop our sample in. Again, you should have a reference in the back compartment of the commercial spectrometer and your sample in the front compartment. and we'll let that run. So that's the background scan ready. Click in here and you can add in your file name. I'm just going to put in the metal orange. I'm going to take my sample, the one that was in the homemade system, I'm going to place it into the commercial spectrometer. Again, you will have a blank. Click on edit, 700 to 400, 1 nanometer data info. We'll do it at a medium speed. We're measuring absorbance. It's going to take about 50 seconds. Close that. Close after cancel. I'd already set it up. So press start. And we'll see our spectrum here now on the side. And we should see something similar to the one that we recorded from the homemade system. Okay, so that's the scan complete. We can click close for a time being. If I click on the cursor icon here, I can bring up the crosshairs and I can measure the height of this peak at 506 nanometers. It's giving me an absorbance value of 0.8577. I plot that value as a function of the concentration of metal orange. But just to compare that system, so that's the commercial system over here. You can see the absorbance bands associated with it. And when I place the same sample back into our homemade system, we can see that we've got a peak centered here about 520-ish. This is at 506, so it's not exactly the same, but it's very, very similar. Okay, you have a similar profile. It's a little bit skewed here, just like on this one. So that's it. You're going to measure the height of this peak on this system compared to the heights that you measure on this one. So that's it. That's what you've got to do. Okay.